Welcome to the video for Chapter 9, Lesson 6, Proportional Parts and Parallel Lines. By the end of this lesson, we'll be able to answer the question, how are transversals related to similar triangles? These three pictures just show you a progression of how we get with what we've started with so far and where we're going. So this first triangle has one parallel line, and this is what we have been dealing with in the past couple lessons. And then so if I just add in another parallel line, it gets us closer to what we're going to be talking about today. And then the last one is really what we're going to be talking about, which is now notice that we no longer have an official triangle up top. It's not closed and the lines are extending. So now we're just going to be talking about the parallel lines and the transversals. And we're going to be talking about more than two parallel lines, and how that can relate to the triangle similarities and proportions that we've already created. So this is a progression of images that we're looking at here and how we get from one to the next, and this is what this lesson is really going to be about. So when two transversals intersect three or more parallel lines, the length of their segments are proportional. So this first diagram again is what we've been dealing with, and then when we have these two parallel lines, their segments, this top segment is proportional to this one the same way that this segment is proportional to this piece. And so when we have three or more doing that, we also have proportional parts set up there. So this is two transversals. So here are the transversals, really like the left and right side of the triangle. Those transversals are intersecting three or possibly more parallel lines, then the length of their segments are all proportional. And it really comes back to this idea of the triangle that gets created with the parallel lines. So these problems themselves are all pretty basic. We're just going to set up a proportion equation. Just make sure that you're following some sort of pattern. So 3/4, so this is the left side. The 3/4 is the left side, top, bottom. The x over 6, the x and 6 are the right side, top over bottom. And I'm referencing that because you just don't want it to be 3/4 and then 6 over x. It has to be 3/4 and x over 6 because the 3 and the x match and the 6 and the 4 match. So we cross multiply to get 4x and 18, and it looks like we're going to get a decimal here, which is totally fine. So we get x equals 4.5. These problems are really only going to get more complicated depending on the algebraic expressions that are used. But we have our parallel lines, we have our transversals, and so we're just going to set up a ratio, and I'm going to set up x plus 2 over x plus 1, the left side, equals 20 over 18, which is the right side. And again, the x plus 2 and the 20 are on the top, the x plus 1 and the 18 are on the bottom, much like they are in the diagram itself. And so now I'm just going to cross multiply and solve. So I got the value of x to be 8. Going back to read the question, make sure that I've answered all of it. It just says to find the value of x, which I did, so we are done. This problem is set up just a little bit differently in the fact that we are given this entire distance here and not all of the little pieces. Now I know that this is going up and down, and so we're not really sure maybe if this matches or not, but this is just the way that I could draw it easily. So this distance is 15, so that makes this distance here a 6. So we're just gonna leave it like that, and we'll set up the proportion equation x over 12 equals 6 over 9, cross multiply and solve. So we get x equals 8 again. The other option when we are given these whole distances is that instead of trying to find these missing pieces, we can set up a proportion where maybe we have the whole over the piece or the piece over the whole. You have that option to flip it as long as you're consistent on both sides of the equation. So I'm just going to use the whole over the piece. So that means I'm going to have 36 over 16 equals the x over the 12. And I have to put the x over the 12 because the 36 is the whole, so the whole needs to be on top on the right-hand side also. 16 is the piece on the bottom, the 12 is the piece that also needs to be on the bottom. That's just consistency to make it a proportion equation, and then we cross multiply and solve. So in this case, x equals 27, which to me, that kind of stood out to me to be a large number, but we have to remember that from the diagram, that's representing a larger distance than just a little segment. Our final example is just a little bit more complicated, but whenever you have these more complicated examples, the job for you with these proportion equations is to look for the set of information that you have numbers for in both pieces. So in this example, it's going to be the 12 and the 16. So the 12 and 16 are both on this same transversal to the right side of this same transversal, and I can use it with my x over 10 to solve for x, and then I can use it with my 8 over y to solve for y. So when I was solving here, I just wanted to show you the two proportion equations that I'm going to have set up. I decided to put the 12 and the 16 first just so that you could see that that was consistent and that information is what I needed to take from the picture first. I understand that it's on the right side, so we may be tempted to put it on the right side of the equation, and that is fine, but I'm choosing to put it on the left so that you realize that that's where I need to start. This 12 over 16, I needed to find that relationship first. So the 12 over 16 is going to equal the x over 10 because the x and the 12 are both on top. 12 and x need to both be on top in your proportion equation. So when we go to solve for the y, I don't want you to just automatically put the y up top because the x was. In this example, the y matches with the 16. They're both on that bottom piece. So in the equation, they also need to be in the bottom. So I'm just going to go ahead and cross multiply and solve. Looks like both of these examples gave me non-whole, gave me rational answers. So 7.5 is what I got for x. And then this division ended up giving me a repeating decimal, which is a fraction. So 10.6 repeating is 10 2/3. So that is the fraction that would represent the value for y. And that's it for this proportional parts and parallel lines. So how are transversals related to similar triangles? Transversals are like the sides of a similar triangle, and they create pairs of proportional segments.